Okay, hi and welcome. Thank you very much for having me. My name is Späti. I have the pleasure to show you today how we use Dagster at Rohde and Schwarz, mobile network testing. A little bit about myself. I'm a data engineer. I'm an author of my little blog where I write also about data engineering stuff, and I'm an early user of Dagster. Rohde and Schwarz is a big company. We have over 12,000 employees around the world. We specialized in electronic test equipment, broadcast and media cybersecurity, radio monitoring, and all kinds of radio communications. I myself, I'm located in Switzerland, where we work at a product called Smart Analytics. This is it's actionable benchmarking, so you can compare different network providers to each other. You have kind of a business intelligence overview to really see the mobile network testing quality, so you can see how is my network doing compared to my competitors, where can I improve, and where is my bottlenecks in my network. And as mentioned, my blog where I write about the data ecosystem. To go a little bit more in detail what we do, so our main goal is to provide the tools for our customer to improve the quality and performance of the mobile network. So on the downside, you can see the car. So this is the mobile network testing in Africa. So there is not always streets, but we have equipment that you can see on top of this car. There is actually, we put all of our smartphones in there. So we have a QualiPoc, which our software is running on. And you can either put that in a car or you can also put it in a backpack. So if you would like to measure the network quality in, for example, like in a metro or in a football stadium or so, then you can use the backpack, put in the smartphones, and then configure what kind of test you would like to do. So we can configure like YouTube test. We can, the phones, they will call each other. They will call WhatsApp calls. They will upload to YouTube. So they will do all kinds of different test scenarios that hopefully the real user will also do. And then at the end of the day, you get a measurement file, and then that gets uploaded in our Smart Analytics. In our Smart Analytics, we have like a time series and statistical. So if you look at the architecture, this is actually the testing going on. So during the day, several cars, several backpacks are collecting these measurement files. And then typically during night or in the evening when you're finished measuring, you upload it to our data warehouse where our custom ETL is running. So this is where all the magic happens, where the data is transformed into fact and dimensions. We clean the data, we transform them, we aggregate, and then we put them into the SQL server for the time series analytics. So if you really want to drill down into the, let's say in the protocol level, what happened when a call has dropped, why it has dropped. So that's where you use the SQL server, or also if you want to plot the points, so the measurement points on the map, you would typically use the SQL server. And then we use the analysis service where this is our cube. So for statistical reasons there you can have overall statistics, how your network is doing compared to your competitors, what tests you have actually measured, how long, and all kinds of statistical measurements. And then the motivation for us for using Dagster. So we want to bring this ETL into the cloud, and we would like to manage all this logic or this ETL logic in a central place, and also being big data ready with in the cloud. As you know, there's a lot of open source tools which you need to mingle together, and there we just want to be ready to connect all of these tools and also have like a state-of-the-art tool. So as said, from on-premise we went to the cloud. We also want to scale out. So at the moment we have SQL Server that can only scale up, meaning we need to buy a lot of expensive hardware in case we have a lot of data, which costs a lot, especially if you have idle time. So you pay the cost anyway. So, and in the cloud, we we want to use more cheaper machines and only scale up if we really need the resources. So we can really also scale down and save money when we don't use any kind of ETL or only limited amount of queries. And then generally we want to also overcome the ETL processing, because that took longer and longer, especially for our big customers. They're collecting more data, and also with the 5G and 6G in the pipeline, there is coming more and more data, which we need to be ready for. And also query time, we have a lot of percentile queries, or medians. So in that matter, you really need to sort all the data to find your median. And that, of course, you know, when the bigger the data is, the longer it takes. And there we really got on the limit for bigger data. We also have a web UI, as you've seen before. And there we really need seconds response time. So the user they want to have this dashboard kind of feeling where you really drill and slice on the fly, and they don't have time to wait. So we need a really fast response time. That's then how we look at our architecture today. So we use the browser for accessing our smart analytics. Smart Analytics is then is an in-house built tool with Node.js, Angular, and C# backend. We also have other query types like Tableau. So users or our internal users can also use Tableau for querying the data directly. We have Jupyter notebooks to do ad hoc analytics or machine learning models. And then the measurement files, the ones that we talked about before, they get uploaded directly in our S3 storage. And there we ingest into our data warehouse, which is Druid. Apache Druid is our replacement for our cubes. So it is well suited for us because it has a sub-seconds response time, also on large data sets. And it also, the architecture is made that you can really differentiate the ingestion to the query time. So even though we would load a lot of data, the query time is not interfered at all. So this makes it a really, really good choice for us. We also use Spark for processing the data and also creating delta tables. We have general service in our Rohde and Schwarz cloud. We use Kubernetes for that. And then there we get like monitor logging, resource scaling we get out of the box. And then of course, the heart is Dagster, where we really put all our code into. So the import pipeline is mainly based on eventing. So we use a lot of event-driven pipelines. So if the customer uploads files, it gets triggered pipelines. And then from there, we use other sensors or events that take it to the next pipeline. We also have a so-called adoption layer where we do the data processing. Let's say if we have a version upgrade or we do other calculation or machine learning models, that's done in this bucket here. As mentioned, the sensors is a big part of it. So if you have never used sensors in Dagster, this is how it looks on the Dagit UI. So it's very nicely done that you can really see all the dots. That's actually when you trigger a new sensor. So there you can say how many or how often it should poll, and then it would check some kind of Python logic, and then we'll start some jobs so you can see which got spawned, and then you can really click all the pipelines and see which pipeline has been started. So this is from the UI perspective a very nice way, but also if you implement this, so the only thing you need to do is actually to put an annotation at sensor and name your pipeline you would like to start. And then for us, it's very handy. We use S3 mostly with sensors, and there we can build in some glue logic. So we define which files we would like to read. You could also add more logic, and then we just spawn pipelines out of each file. So this is a nice way to add a little bit glue code there and to spawn your pipelines event-based driven. this is, let's say, our import pipeline, just to give you an overview how this looks. So we don't have like an overall pipeline, as mentioned before. If we upload our zipped files, sensor get triggered. It will like parallelize per file that get uploaded. All of the unzipped files get uploaded again. And then we take a next sensor that takes each of this file individually and run the ATL pipeline on it. So we really try to scale as much as possible. That's also why we use sensors, because we have different granularity between these sensors or pipelines. This ETL pipeline will then do all the logic which we had before. So we have our facts and dimension coming out here as a Parquet file. And then this gets, based on fact tables, gets ingested into or created as a delta table on our S3 storage. And then we also with Python ingest it to Druid. So we have a very nice flexibility that we have machine learning use cases or the experimental stuff. We can really use the delta tables. We can also do joins and more sophisticated things, whereas in Druid we really use for our sub-second response time for the application. This is the pipeline part, but we actually also use Dagster for provisioning. So whenever we have a new user or we have a new tenant in our cluster, we use Dagster to create the buckets, to upload the secrets to our vault. We create the Druid account. So the more we use Dagster, we also find new use cases that we can actually integrate with it. So it's not just for data pipelines that which is very powerful for us, but also for other kind of administrative tasks that we would like to automate. Exactly. And then we also use assets. So assets is the part where you link your data to the computation. So it's also maybe a rather newer feature, but it's very well suited for if you want to add metadata on, or you also want to show your persistent data to your customers. So we played around with the ETL. So we added some size or durations to it, and then we could immediately see if there was a spike in some ETL jobs, or then we could actually, you can then on the UI, you can also click on that point and really drill down to the actual pipeline to see which file it was and what happened there. So this is a very nice feature for us, and we would also like to add more. So we try to create assets for all our persistent Druid tables and also for our delta tables. And in the future, we also like to try the data lineage that just got added to Dagster, because we have this event-driven pipeline that from the zipped files to the actual Druid fact data table. Sometimes we have some wrong data, and then it would be nice to see where this data is actually coming from. And there we were hoping to use the data lineage feature to actually document it and also make it available for all our customers and also for us as engineers. If you haven't used assets, it's actually quite easy. The only thing you need to do if you have your solid, this is the one part of your pipeline. Beside yielding your output, you just yield another asset materialization, and this is actually exactly what we do here to get the output that we just saw before. So we just add a key, which is the unique identifier. So here we are still playing around if we want to have it on each fact level, or we would like even to have it a little bit higher level. And then Dagster is like dividing it, but here you can add descriptions and then all the metadata, which we have seen before. So so far we use it, let's say, for quite a bit, and the advantages for us using Dagster is, in the first place, also that we could replace our custom-based processing engine that we used on-premise, but now we have massive out-of-the-box features. So we just have restart capabilities, we have backfill, we have the dependency management. We see what's job, we have the UI. So we have different modes, so you can just switch from production to local. Just you have these modes that you can just switch. So all of these features are tested and stable, so we just get them out of the box. So this was a nice implication for us when we start using Dagster. The beautiful Dagit or the UI is very nicely done, and it's shows exactly what you need to know. You see always the state of each pipeline, what is the current jobs running, and you get rich metadata. That's also a big plus for us, that we can really add also customized metadata to make available in the UI as well, easily, without doing too much. The problem solving is also a big thing for us. Before we used other methods. Sometimes it was actually hard to find the error itself. So we had to go through Kafka pipelines, or we had to really find the error. And sometimes we couldn't even find it. So with Dagster, you really have the error straight in your face. So you really, you can really start solving errors, because and in case you miss some data or you don't know why the error happened, you just add more meta information. So at the end of the day, you just have an easy way, or always have all meta information to solve these bugs. We also have users or developers that didn't come from the data sphere, and they have told me that it's easy for them to grasp the concepts. So all the concepts with the resources and the solids and the pipelines, it made sense to them. So we could also have quite fast speed up with new developers using Dagster. And it's actually very pleasant to write pipelines when you have such a nice framework around you with, there's a lot of thoughts in it that you don't need to think about. It's just built in. And then everything is self-documented. So you don't need to actually like draw diagrams anymore, because the pipelines in Dagster are self-documented. You can really see each steps. You can even put SQL statements inside there to really see what's actually going on with the assets as mentioned. And you're spending less time actually explaining what's going on, but you can really discuss business transformation and logic, what needs to be done. One of the biggest thing for me was the reusable of code. So once we had before we had microservices in Python. So first things we could really easily move them to Dagster. So we had classes, and then we just added them to resources, and then we already had them inside Dagster. So that was a very elegant way to use existing code. So for us, it was in no time we could move the stuff. But also the resources are specifically helpful for us, because you write the code once and then it's tested, and you can use it everywhere in the solids or in all your pipelines. So you don't duplicate your code. It also reduced the boilerplate code for us, because when you have microservices, you tend to integrate the logging, the restart, and so on. These kind of things you always need, but you always re-implement them normally when you have different microservice. But with Dagster, you do that once, or you even get it already out of the box, or you build it yourself, but then you do it once. And that was very good for us. And it's also functional by design. So when you use Dagster, all the pipelines are actually built functional, which also reduces management or ease up the maintenance of code or restartability. And all of this comes just out of the box just by using Dagster. Here is an example of how we use resources. So for example, we have a Druid resource. We took our classes that was already there, the Druid connector, with some methods that we use. And then you just add the annotation, add resources. And then you give it all the passwords and usernames it needs. And then you do that exactly once. And then you can use it in your pipelines just by specify the resource. And then you can access this with the context. So the context is very powerful. So all resources that you specify, you can just with context resource.druid, you have access to all these resourced methods. So besides that, the context also has additional functions that you have, for example, the run ID. So you really get a powerful tool there. and you don't need to fiddle around with passwords and usernames, because this you do once in the resource, and then you're ready to actually do the pipeline logic, which is is also another very nice feature of Dagster. When we started, there wasn't yet the Kubernetes deployment, but just when we were about to start with Kubernetes, actually there was, and so we are heavy using Kubernetes. It's also very handy for us because we have a SQL server on Linux in one deployment, and in another one we use Spark. So it's easy to separate them with the user codes, and we can also scale out easily with new pods, and it makes things very easy for us and also understandable what's going on. And yeah, that's also a big plus for us. It's Python based, so the language of the data nowadays is Python, so it's easy to learn and to adapt for engineers. And it also supports SQL statements, so you can have your solid that takes SQL statements, and then you can easily integrate that as well. Or it has also powerful extensions like dbt and other things that you easily integrate with it. So, and yeah, that's this. And the next steps. So we're not yet using that much unit testing and smoke tests, so we would like to improve there. At the moment, there's a lot of manual testing, and yeah, we would like, of course, to have some test files that automatically get tested. The documentation, we would like to use assets more intensively, maybe even automated, integrate the data lineage feature. We started some Dagster pipeline guidelines just to have some best practices around the, let's say, when to use assets, what is the namings, how to use resources. So it's very basic, but we also like to start growing that one. And specifically, I would also like to try the dynamic orchestration. As told before, we have many sensors starting low-level pipelines, but with I would like to try if we can also use maybe one pipeline that spawns dynamically all the sub pipelines. And also partitioning we're not using yet. Everything is based on files in our environment, so partitions would make sense there as well. Yeah, that's it from my side. Just contact me anywhere if you have some question, or yeah, feel free to ask them later on. Thank you very much.
Thank you, Simon. I also wanted to give Simon a special shout out. He was an extremely early user of Dagster and has produced a ton of great content about using Dagster on his blog, which I highly recommend everyone here to check out.